Hello and welcome to the Our Connected World podcast brought to you by TE Connectivity. I'm your host, Michelle Dawn Mooney. During our previous discussion, we looked at the challenges in evolving and implementing eVTOL technologies. And today, we are going to expand on that conversation by now looking at eVTOL operational and maintenance requirements, as well as requirements for eVTOL charging infrastructure. And I am pleased to welcome from TE Connectivity, Martin Cullen, Senior Manager for Business Development in the aerospace market, and Matt McAlonis, Engineering Fellow for Aerospace Technologies. Martin and Matt will share their insights about the state of eVTOL architecture, infrastructure, and its evolution with their takeaways from attending the 2024 Vertical Flight Society show in Santa Clara, California. So thank you both for joining me again. Great to have you here.
Thank you, Michelle. Great to be here again.
Thanks, Michelle. Good to see you.
I'm so happy to have both of you here. We had a great conversation on the first episode. I highly encourage all of you, if you've not listened to that, or even if you have listened to it, go back and listen again, because it will definitely be helpful with what we're talking about here today. So I don't want to waste any time because I know we have a lot to get to. So let us dive right in. Martin, starting with you. Where is innovation happening in eVTOL architectures, and what is the design challenge around these?
These eVTOL designs have been in work for a good number of years now, to certain degrees of maturity with each different manufacturer. But overall, I think we're still in an exploration phase to really kind of understand what these architectures are going to be looking like. So we still are seeing innovation in how these aircraft are going to be configured and put together. Evidently, still the prime source of innovation, I believe, is in the battery technology, whether it's cell chemistry or battery packing. How you connect that to the rest of the distributed electrical power system. So there's still innovation at the system level, and we will, I think, see in the very near term innovation coming down into the component level as well. So at the moment, it's still at the system level, very much focused on the battery. And once we're kind of past that stage of a certified aircraft, I think we'll see the second stage of looking at the component and how that can be innovated for future benefits.
As a follow-up to that, what does maturity in eVTOL architectures look like?
It's converging. Like I say, there's so many different configurations out there, and there's different applications where you see an optimized airframe, an optimized configuration that will fit better in some use cases, more so than others. And over time, we'll eventually see a convergence of what the best configuration is for that particular use case. We have things to think about: redundancy. What is the redundancy systems within each of these configurations? How you have dual or triple systems between individual power packs and the motors and the inverters. How you control that through the PDUs, the power distribution units. So there's still going to be some optimization, some innovation on that level of architecture, including the charging system. We're seeing different systems where there's 1, 2, or 4 inlet chargers on the aircraft. So how that is managed, how the different failure systems are managed, is still, I think, yet to be worked out. So we'll see, I think, some convergence of an optimized design as these aircraft get used in the first 2 or 3 years of their operation.
And it really is exciting to have something that is changing. The technology is moving so fast, and it's a really exciting type of technology there. So, a lot of people might be thinking, what about mass transit? And to play devil's advocate here, what must be addressed before eVTOLs are a viable technology for mass transit, such as current thinking about range anxiety and then predictive maintenance?
Yeah, so what we have again here is, first of all, mass transit. I mean, the concept of mass transit and eVTOL is no, eVTOL is not there to answer mass transit. That's going to be your buses, your coaches, your trains. That's what mass transit is. What we will see are different mobility routes open up with eVTOLs, going across deserts or lakes or mountain regions. And when you start seeing those use cases, you've got to start thinking about how are these aircraft going to be maintained, serviced at their point B destination. So you've got to think about infrastructure, you've got to think about repairs, servicing, you've got to think about the people that's going to be doing the job, you've got to think about how they're going to get components and other repair equipment to these locations. So first of all, it's very important to kind of, and I guess it's a bit catch-22 of understanding how these aircraft are going to be operated, what kind of infrastructure, services, people you need at these locations, and then how you can expand that to go to different areas, different routes. So it's going to be a little bit, let's say, catch-22, again, an evolving capability as these operations are explored, essentially. I think, again, with all of this domain, from the components to the subsystems to the airframes to the actual in-service operation and how passengers are going to even get onto the aircraft, I think it's still going to have to be a bit of a find out and see when the rubber hits the road.
Yeah. And Matt, there's a lot to take into consideration, as we just heard Martin talk about. So how can this be addressed without compromising the design or draining other systems?
Yeah, there's a lot of technology that is new, and electric propulsion, pure electric propulsion is something that needs in space and aerospace terms, a technology readiness level to be considered reliable and repeatable. So some of the things that we're looking at in some of these new aircraft are things like flexing and articulating motors, which most aircraft have a static motor on there. And, so we make a lot of things like wire and cable systems that aren't initially designed to have that type of flexure in them. And so there's innovation happening with the types of aircraft, the design of aircraft. So we need data to understand what maintenance looks like. So right now, when an aircraft lands, it goes through some routine inspections, but inspecting things like the cables typically isn't part of the process today. So as we think about draining a system, so to speak, and even like the ranges of these batteries, the electrical integrity of that electricity on the top of the charge and the bottom of the charge is different. So how far down can you take your batteries and still be capable of like an emergency loop or something, or a redivert? So these are things that I think, as we think about the electrical systems and getting data on these systems, is very important to get that technical maturity level.
What do you think is limiting OEM capacity to drive innovation and then adoption at scale?
Yeah, that's a good question. I think when you think about these early nascent designs that are just starting to fly, one or two aircraft are flying in service. We live in a highly regulated industry, and it has to be, because it's, if you have a failure, that can be fatal. And it's not just the crash of an aircraft, but it's also when high power electricity is used and fails, it is very explosive and dramatic. So when you think about the lightning bolts that, if you have a failure that could occur, you need to keep things safe. And so there's a lot of new technology, power levels that typically haven't been seen before. They're typically in the range of probably 3 times what our current aircraft are seeing in terms of the voltages. And so with these high voltage systems, we have to make sure we have the right testing to make sure the systems are safe and reliable, and again, understand that maintenance. So when you push innovation, you really need to understand not just how it works, but also how it fails. So what are the degradation mechanisms that we need to look at? And when you think about scaling, so scaling and building these aircraft are different. So the manufacturing processes and methods are new, and how we wire them and install electrical motors versus traditional aircraft engines is different. So those are things we have to have new processes. Like, how do I take my batteries in and out? Like, that's not part of the standard maintenance. Or how do I inspect some of these systems? So this all has to be studied. It has to be approved by the FAA, and we need the ground maintenance infrastructure to be available as well. So you have new types of mechanics and technicians that have to be trained. So there's so many things that will need to be certified. When you think about just aerospace in general, there's several types of certification. One is your design, one is how you make it, one is how you test it, and one is how you use it in operation. So all four of those areas have to be considered and have confidence in them.
Let's dive a little deeper with design. How could advancements, because that's the exciting part, right? A lot of advancements here. How can they affect connector design going forward, especially for enabling more efficient power distribution and thermal management required for robust EV architectures while minimizing impacts of a high vibration environment?
Well, that's a very
A lot
loaded
there.
question. So yeah, connectivity is essential here, electrical connectivity. And so what we do with customers is we put a schematic together from the charger to the energy storage area to the power switching area, the whole way to the inverters and motors and all that connectivity in between and how they manage their harness. So when you think about all that content, that's weight. So the first thing we look at is make sure it's weight optimized. And there's different things like the geometries we play with and how that can conduct electricity more efficient and amperage more efficient. So we have to look at the electrical fields around these components. We want to make sure they're as light as possible, but they have to be as robust as possible. So if something like a charger is being mated to every time, that doesn't necessarily have to be, that's not being charged in flight. So that's not as a concern for vibration for us, but the things that are connected to the battery that have to be reliable in flight, that's where we typically will focus and optimize those things. So when we deal with flight, we also have things like takeoff, landing, cruise, where we're looking at all the different vibration profiles and the current carrying profiles during different situations in flight. So we do thorough analysis on these things. But again, we try to use our engineering analysis tools and simulation tools to make sure we have optimized product. Weight is the thing that is very different with conventional aircraft where you're burning fuel. Your batteries don't get any lighter when they discharge. So you're literally carrying around dead weight. So that's an area that we really have to focus on is our materials we use for weight reduction.
Martin, I want to turn to you now because we have a great product, right? So we're talking about how to get that product as perfect as we can, at least at this point. So let's talk about, though, servicing that product and keeping it sustainable. What is needed to sustainably maintain and service eVTOLs over time?
I think, again, that's where we don't have all the answers. For sure, there's a lot of experience. Helicopter operators have been gaining for decades in remote locations. So they have a good understanding. But then when it comes down to high voltage applications that fly in harsh environments, they're going to be unique instances that they've never experienced before. A lot of these aircraft have tilt rotors. So you have bearings that are moving, you have cable that is flexing. These aircraft flying in a sand and dust environment, sand gets everywhere, dust gets everywhere. So how does that get into these aircraft, and how is that going to impact its operation? But there's a lot required for repair, maintenance for any aircraft. And it all comes down to what processes do you have, what people do you have, do you have a supply chain in place for repairs? It takes up to 4 years for an aircraft mechanic to be certified. So, what training is there out there for electric aircraft? Is there a certified eVTOL mechanic out there? I don't think so, because we're still going through that process. So, I think we need to bring across the experience from the helicopters operations. We have to look at what we think is going to be potentially a situation of look for a potential weak points in the aircraft that where we think we can apply our knowledge and our help in designing these aircraft, and also how can we support the considerations about design for repair, access, for example, how you disconnect quickly and easily, and how you get to the right level of maintainability requirements for these aircraft. So, yeah, it's still a phase of exploration, and we're going to have to learn as we go in many instances.
I was going to say, really is a learning curve. We're talking about, there's a lot of unknown. You're admitting we don't have all the answers. So, to that point, what in the field operational and maintenance requirements need to be defined and addressed, maybe at this point, before eVTOLs can even become a common form of air transportation?
I mean, the word comes to mind down to me is inspection. If you've probably seen pilots going around your aircraft before you take off, and they do a safety check and an A check on the aircraft. If you've got a PPL, you can get a private pilot's license. You'll fly yourself. First time you fly the aircraft, you have to do a thorough check. The second time you fly the same day, you can do a lower check. So, what level of inspection is going to be required before you take off with your passengers? How are you going to monitor the ingress and egress of passengers that could damage the propellers or another part of the airframe? So regular inspection, I think, is the level of safety checks before you fly each time. There's going to be quirks. There's going to be distinct requirements, I think, on these aircraft that you won't see elsewhere. From inspecting, like I say, propeller tips all the way down to looking at the electrical system in itself. So I think that's the first thing we kind of really do have to kind of get understood in this industry.
Matt, when it comes to the eVTOL manufacturers, what operational and adoption concerns are top of mind for them?
Yeah, I think it's similar to the automotive EVs today, which is charging. So when you need to charge and where you land, so these are very portable aircraft that could conceivably land anywhere that has a flat space. The question is, how much charge is left to get you to a charger? And then when you land, what kind of charger is there? And there's a really interesting thing we learned last week at the Vertical Flight Society event, the transformation of vertical flight. And it was about chargers. And two companies emerged and said, pick mine, and they had different interconnects. They had different systems. And you want to charge as fast as possible. But when you charge fast, that means it gets very hot. And if the connectors are getting hot, if the batteries are getting hot, where are the batteries located? And in some of the designs, we've seen batteries literally surrounding the passengers. We've seen some up in the wings. So can you imagine, what that will look like if you're inside of a fuselage waiting to take off and they're charging? It's getting very warm and very uncomfortable. And so there's things like that which are still, I think, going to be thought through. There's a lot of work needed to supply this power. So do you have the physical infrastructure on the ground to, if you're landing on a roof, is that building wired for this megawatt type of charging system that's needed? Probably not today. And so there's a lot of things like that that really have to be work through. The other question I would think about is even like, can you charge in the rain, and what does that look like? And so there's so many new things that will have to be, vetted out before the operational is certified.
And Martin, as a follow-up to what Matt was just talking about, what must manufacturers and transport companies do to make eVTOL a feasible long-term investment?
So in terms of service and repair and operations, I think it's, as Matt kind of touched on, it's standardization, particularly of charging and the infrastructure required, and that can be to the particular mating profile of the charger of the connector, to the data download, the CAN bus protocol. Now, we're kind of familiar with OBD2 in automotive. Do we have something similar in aerospace that is standardized? Do we have a common way for maybe using the same charging station with different charging inlets, plugs themselves? Is there any kind of cybersecurity type concerns of connecting these aircraft to chargers? Maybe some of that are remote, or even perhaps in a busy area. So there's the cybersecurity aspect. There's the data integration, the standardization of charging, maybe the standardization of operations. I have, if you look at current commercial protocols, you cannot refuel while passengers are on board, for example. So does that mean you cannot charge your electric aircraft when passengers are on board, or how far does it have to be away from it? So there's some, I think some regulations, some standards have to be kind of put in place and well communicated to help the design of these aircraft, and also to help the operation processes be quick and allow these aircraft to operate as we intend.
Let's talk about infrastructure. We have heard this term all over the place now, especially with, so many people driving electric vehicles. So what does the charging infrastructure look like for eVTOLs?
Again, Matt kind of touched on this with the different types of proprietary IP charging inlets. Now, I've seen many companies come to the market with their idea of charging units, remote charging units at large kind of airport installations, through to remote helipads or vertiports in parking lots, in urban parking lots, or on top of skyscrapers. So, it hasn't been implemented yet. There've been trials done, experimentation done with these. So again, I think it depends on each use case. If you're shuttling back and forth between an airport, then you can use the airport facilities. That's fairly straightforward. They have a good infrastructure of high power connectivity there. But then when you start looking at what about a remote vertiport and in the Norwegian fjord somewhere, how do you put an infrastructure in there? So it can't be heavy. It's got to be lightweight. You've got to be able to perhaps leave it without much maintenance. So just as these platforms are going to be individualized for the use case, I think we'll see the charging infrastructure really kind of be optimized for the particular use case as well.
And with that, of course, there are challenges. And when I mentioned that we hear a lot about infrastructure now, because a lot of it is that the infrastructure that is needed does not necessarily exist in many parts. So what are some of the challenges to making this infrastructure available at scale to support broad use of eVTOLs?
Again, I think we're touching a little bit about standardization. How can we be certain that we don't end up in a Betamax situation where everyone's invested huge amounts of infrastructure into one type of connector, one type of charging system? How can we be brave enough to provide the significant numbers that's going to be required? Because as we all see today, traveling from the West Coast to the East Coast in the USA, or or traveling through Europe, there's so many different providers. You have to have so many different apps, and in some countries in Europe, actual physical cards to use these charging ports, not just an app. So we're going to have, I think the issue really is more about process and standardization than the technology itself. So I think we have the technical capabilities today to do it. I think it's the how can the community come together and make sure we can provide those solutions. We see companies like Beta have their own charging network in place. Companies like Archer putting forward their version of what charging solutions may be. So we can't have all these different types of infrastructure at every single location. And I think we want to see interoperability of aircraft at a vertiport. So can we come to a consensus on how we do that? And that is still, I think, very much to be matured as we go through the initial operation or kind of learning and exploration.
Learn as you go, right? We've kind of talked about that or alluded to that a few times. We touched on manufacturing. Want to talk about that as well as regulations. What is really required before eVTOLs are profitable to manufacture and operate at scale?
Yes, I can take that. So the market is new, the product designs are new, and you need economies of scale to happen. And right now they're making one-offs. So anytime you make just one of something, it's very expensive to do that. And so you're seeing a lot of evolution in how they're thinking about building and making and getting their manufacturing and supply chain stable. So that's really, I think, important for profitability. But the other thing I think that is a really interesting piece of this ecosystem of profit is, electricity in California is very different in cost than it is in other places. And so, how does that play into this business is going to be really significant. So, I think there's going to have to be a little bit of help here in operation and profit. But manufacturing, again, I think just needs a state of maturity and stability, because there are new things being built and understood. And until they get production lines scaled up, we'll have to wait to see some profit there. And even from the personal comfort and you as a passenger making that choice, I want to fly or travel this way. Like, it's a new thing and no one is doing it today. So what will it take for you? Like, how bad does traffic have to be? Or, will you feel safe getting into one of these vehicles that are brand new? So I think those are a couple elements that would be interesting to see how that plays out.
Yeah, and I could probably add to that actually, because I think cost comes in when you have people involved. So and that is within aerospace industry, that comes down to how often do you have to maintain an aircraft. The maintenance per flight hour is as a big key parameter, and that's where eVTOL in particular does have its main advantage over helicopter and light aircraft use. Simple systems compared to a traditional aircraft. The second one is design for manufacture, design for assembly. So how can components be designed to speed up manufacturing time, repair time? And that's, I think, again, the second phase of eVTOL. We'll start seeing some optimized airframes, optimized components that really move us towards more of an automotive style production line than we currently see in aerospace, where you build in, Airbus with the A320 are looking at 70, 80 a month. But that's dwarfed in comparison to what the automotive industry are doing with thousands a month. We're going to be somewhere in between. But so I think there's some work for us as engineers to really look at how we can reduce the operational cost, all the labour costs associated with eVTOL.
I want to talk about regulations for a minute because that plays a big role here, especially when you have a newer technology. So, what government and industry regulations could either prevent or accelerate adoption globally?
Yeah, so we're seeing quite a divergence right now with what EASA are stipulating and what the FAA are stipulating. The FAA approach to regulation is picking and choosing from existing certification routes and procedures. EASA, on the other hand, are evolving a completely new special certification process for eVTOL. So, and they're not harmonized. There's some work that hopefully they can become more harmonized in a couple of years' time, 2026, I've seen. Um, but at the moment, they do require quite a different approach to the level of safety of the complete system. Um, at the moment, Europe is stipulating a higher safety requirement, 10 to the minus 9. And in the US, the FAA depends. It's 10 to the minus 6, 10 to the minus 7, or 10 to the minus 8, depending on the application, the airframe, etc. They're also stipulating, I think, a 45-minute divert time to have enough charge for 45-minute divert time, but that is longer than most aircraft are designed to fly for right now. So that doesn't quite tie up. We're also seeing the mandatory use for trainer aircraft to have dual controls in the US. So they're not harmonized. So does that mean aircraft that are certified by the FAA cannot fly in Europe? It looks like that might be the case at the moment. Does that mean European aircraft are inherently more costly to build and therefore to buy than a US counterpart? Does that put European airframers at a lower level of attractiveness in the market? So there's two regulations at the moment. The different approaches are definitely looking to be cause complications for a global uptake to one standard of regulatory oversight, and therefore the design and therefore the operation of these aircraft. So yeah, so at the moment, I think we are in a case of when we have a situation where these aircraft, the operation of and the global uptake could be impacted on regulations rather than technology.
I want to ask both of you this. What one thing did you learn about at the 2024 Vertical Flight Society show that surprised you, and how might this shape the evolution of eVTOLs in regard to market demand and design innovation?
Well, for me, we usually have a cast of characters that are involved in this industry that we're familiar with, and so we had a booth at the show, and right behind us were two eVTOLs from a company I had not heard of yet, and they were for sale. And so I think there's just so much happening, and we met a lot of new people there. There's just so much happening in this industry, and it's tough to keep an eye on everything there. But there are new players in here that just emerge, so you just never know. You have again, like the top big brands that you're very familiar with, but there's other players in there that are introducing products. So that was a very interesting thing. The one thing that I just want to mention in terms of regulation is Paris Olympics are coming up, and that was a real, I think, milestone a lot of these companies had their eye on for flying, having operational service. And the one thing that happened was the city officials in Paris said, no, you can't fly them here. And it wasn't because of a technical risk. They just did not want to see them or hear them and in their city. So those are things that I think caught some people by surprise. So I think there just needs to be a high degree of comfort level with this as a form of transportation.
For me, I was kind of surprised at not being surprised in some ways. I thought there might be some kind of eureka, some kind of grand announcement about the progress of testing, about the progress of certification or something. It's I can tell it's still being worked, and we can tell. I think there's a lot of people not wanting to give too much away at the moment. There was a lot of discussion on the aerodynamics and the vibrations and the field of these aircraft, and I think that was great to see. Now, for me, the vibration environment I think is another big unknown. So it's great that's being talked about. But yeah, I think I was a little bit surprised that we weren't more certain in a few things. When I say we, I mean the industry. Um, I think there was an opportunity, perhaps that happened behind the scenes a bit more, but I think there was an opportunity that where we could have expected to see some kind of a eureka moment, and I feel 2024 that's still yet to happen. So maybe 2025 we'll event we'll see that announcement.
You're like a kid on Christmas morning and Santa didn't necessarily come how you thought.
Yeah,
So maybe next year. Maybe next year.
maybe next
So,
year.
Matt, I want to pose the next few questions to you and talk about TE Connectivity's role with everything that we're talking about right here. Where is TE in the eVTOL system architecture?
Yeah, that's a great question. So, TE is, our focus is on connectivity, especially electrical connectivity and power switching. And we have a team now that I lead. It's called Advanced Systems and Architecture. So this is literally what we do: is sit with customers, help physically map out what they're trying to connect and how that works. And every piece of this is vital. You can't have any weak link in that system. And so our customers sometimes come to us with things they've chosen that, I can challenge them. Like, why did you pick that? Like, that's not consistent with some of these other high reliability products in here. And they may have borrowed it from automotive grade type product, which has, a very different expectation. If you have a problem with your car, you can pull over to the side of the road. If you have a problem when you're flying, that's something that's a much more serious situation. And so, Martin mentioned before about the need for redundancy and what does that look like? So in critical aircraft systems, sometimes it's double redundant or triple redundant. Well, that's all weight. And at some point you become too heavy and you can't fly and you don't have range. So where we look in the architecture are everything like the ends of the wires with a lug on it. Like, is that weight optimized for you? And the size of the cable, is that the proper gauge conductor inside of it? And the types of insulation we put on top of it, is that as thick as it needs to be for the voltage you're running? Or can it be reduced because you're at a lower altitude and you have different phenomena occurring at high altitude than you do at low altitude? So we walk through the whole architecture with our customers to make sure they have the right products for reliability, but also the right products for weight optimization.
What is TE doing to help eVTOL engineers and manufacturers innovate in ways that support their operating models and long-term technology roadmaps?
So the one thing that we do is, I think because we have other markets at TE outside of aerospace, we can communicate some of this other technology that could be adopted into eVTOL. So the EVs driving today have already thought through things like charging and cooling, the charging systems, why they're charging. And so we can help bring innovation in those spaces where we already have some other industries that are ahead of aerospace. So that's, I think, one advantage where TE can help bring other engineers from our company in to have these conversations. And our roadmaps, we typically look out 5 to 10 years from now. And so NASA has some roadmaps, not just with eVTOL, but how do we get electric propulsion in larger aircraft like regional and other wide body. So there is a roadmap with some timing on that. And part of what we look at is not just the electrical element of it, but other areas of sustainability. So there's a current wave of thinking around hydrogen also sustainable aviation fuels, and a lot of other elements in the technology development. So all these other things still have to, again, we talked about infrastructure. So if you're now going to switch fuels or go with hybrid type of aircraft, you still have to figure out, what that looks like for operation, maintenance, and long-term reliability.
How would you say TE is helping customers meet operational requirements such as weight limitations?
Yeah, outside of safety, I would say weight is probably the biggest topic that we talk to our customers about. And what that enables us to do is go through the types of materials that they're considering. And just a basic example is a lot of traditional power systems are run with copper wire, and we have aluminum wire that's certified to run in aerospace, and it's about half the weight of it. So you have to size your gauges of your materials to be appropriate to handle the current. But those are some of the things that we're doing with new materials. So materials, and there's an area of what we call generative design. So we can use computer models to do analysis of the actual parts and make sure we don't have too much material in there. It may able us to typically weight reduce 30 to 50% if we run through that type of analysis.
You mentioned design. What is TE doing to be more agile in addressing customer design and production requirements?
Yeah, so agile just means you don't need to get it perfect to give your customer a sample. So just be early in your concepts and prototypes, and we have ways to do that today with things like 3D printing, where we can show our concepts usually within 24 hours, where we'll talk about an idea, we can model it and show them a sample of it, like a real sample they can play with, get their hands on. Excuse me. So that's where, when we think about agility, it's about doing our due diligence in the design end of it, and then be very quick with manufacturing methods and prototypes before we have to scale up for mass production.
Martin, I want to pose this to you. How is TE using its capabilities to drive innovation in the industry as well as within its own deliverables?
Sure. So this is what's really exciting about eVTOL. It's a super catalyst for innovation and technology development, particularly in aerospace. If you look at our products in the aerospace business unit, we have relays, cables, connectors, fiber optics. But those are products. If you look about our design capabilities behind there, if you look at our manufacturing capabilities behind there, relays are about high power switching. Connectors are about high mating tolerances at high power. Wire and cable is about materials and electrical phenomena, and how you design the material selection for that. So if you strip the fundamentals behind those products, you have an amazing array of capabilities that TE particularly has great potential in combining for real value innovation, for products, for capabilities for our customers eventually. That's what we're here for. We're here to develop new technologies, new products for our customers to go do and create some exciting platforms. So for us, within aerospace, we have that fundamental potential. But then the great thing about TE is we're very broad in the markets we serve, as Matt mentioned, from devices in your cell phone to components in your car or in satellites or in rockets. We thoroughly have a broad range of expertise that we can rely on, and then we can bring into this new domain that perhaps no one would have thought about before. So that's what I'm really excited about, and going back to the fundamentals underlying the products we sell. So what can we actually do, and how can that actually create this amazing new chapter for TE?
Okay, so speaking of new chapters, let's take a look at the future. What does an eVTOL future look like for you, and how might it influence air transportation overall?
well, hopefully for me, it means I can get back from the airport within 20 minutes, not 2 hours. I travel a lot and I'm used to using trains and buses and coaches. So I'd like to just slip out from the airport and get home to my house here in Bristol pretty quickly. So that'll be a very good thing for me personally. Um, so yeah, for me, I think the future is, I know our strapline is about connectivity, connectivity. So, being physically connected to different parts of the world, I think has great potential for society as a whole. Um, so yeah, being to go able to go places, get better services, seeing different parts of the world. That for me would be a great future to look forward to.
Yeah, I agree, Martin. I think the amount of time we, if you want to call it waste in traffic, uh, last year we were at the Paris Air Show, and the Paris Air Show was just a few miles from our hotel. And because of traffic, it took 4 hours to get there. And that's, when I think about an eVTOL future, I think about just having that ability to have flexibility in traveling. And if I can call up eVTOL to come and pick me up and fly over everything like that. And you think about some of the futuristic movies like Blade Runner, things like that, where you're just kind of floating around and you have this three-dimensional travel option. So, I think about that as that can be our future, and it's exciting that TE can be part of some of these inflections in the world like that.
Yeah, and it's interesting to note that both of you kind of listed personal reasons behind looking to the future because, I mean, I think, that really is the key. I mean, clearly we're talking about TE connectivity and their role in all of this, but it all comes down to individually, we all have those needs. And here we're talking about technology that can really benefit so many people as we head to the future and see how this technology grows. So what is your team watching and enthusiastic about in regard to emerging ideas for eVTOL technologies?
Well, for me, I would say I'm excited about evolution in the battery technology because that's really where I think until we get the energy density to a point where we don't have to worry about weight, and if we could come up with a magical battery that gets lighter, there's some things like that are really critical to innovate and get us to the point where that's no longer a concern. But that's one of the areas I'm really enthusiastic to see if there's new chemistries and if we can leverage things like AI to calculate the proper chemistry for better battery technology and safe technology. That's what I'm looking forward to.
Yeah, so for me, in terms of actual eVTOL technologies, um, there's the optimization becoming effective and efficient with components with subsystems. So, with the move away from hydraulics, fuel within traditional aerospace, some of the technologies about combining products, combining components with systems, thinking about how you integrate with a carbon composite airframe with wire and cable. I think there's a real openness actually to try things differently. I think it's brought about kind of this exploration phase within aerospace that almost anything could be possible with the technologies and the capabilities we have today with digital engineering, for example, and an agile design process. So for me, it's kind of a blank sheet almost when you look at what could be done in this new domain.
Yeah, very exciting. Last question here. What can we expect to see more of, especially around technology integrations and maybe engineering partnerships?
Well, one of the things that we absolutely saw was alliances in the charging networks. And that's when everyone needs a charger. And so if you can get just consensus on what's the best way, that's not over designed, overkill, and optimized. So that's certainly one. I think there's questions about autonomy. Do these things need a pilot or not? And so perhaps there would be convergence in how they operate, and just some of those technical pieces like standard batteries. Like maybe it's not charging isn't the answer. Maybe it's swap the battery out is the answer. So there's a lot of things like that I think we'll see in the next few years. I thought it was interesting that the designs are converging. There used to be a lot of different types, but they seem to be converging into the articulating section of the motors, and also the ones that don't, that they're just used for lift, and they often park them, and then they'll turn the articulating ones for flight. So we are seeing a lot of things like that kind of partnering together, I think, in the recent times.
Yeah, it's interesting because there's two ends of the spectrum. There's those companies out there designing eVTOL that want to do everything themselves, from designing to operating the aircraft. And you get others that are a bit more traditional with using the supply chain to go to the experts for major subsystems. So I think we'll see as the the mass ecosystem kind of matures, I think we'll see a refinement of those partnerships. And I think we'll see a greater in depth desire to be partnered for providing services and supply chains into these companies and to the end user. So I think there's still, again, I'm still learning. There's a common theme on this. But I think we'll explore more of that. I think there's still more to be explored rather than really exploited for anyone's true benefit. There's still this experimentation phase to come out. So we've got to find out what works, what partnerships work, what the emphasis is, and yeah, there's going to be, I think 2024 onwards, we're going to see an interesting time of potentially some acquisitions as well within the eVTOL industry. So don't be surprised if we start seeing that and some of these partnerships begin to converge.
Michelle, one more thing I would say when we think about engineering partnerships with eVTOL is we do see a tight alliance with some of the automobile EVs. And because they have that experience, some are now aligning themselves with some of the eVTOL makers, which makes sense. And you see companies like Hyundai and even Porsche and some of these other type of brands that do have their partner with flying vehicles as well.
So Matt brings a good point about how with startups, we're also seeing a lot of automotive partnerships, and automotive is driving a lot of this early technology growth. You've got to ask yourselves, where are the aerospace primes? Where are Boeing and Airbus and Leonardo? Well, they're coming later. They're waiting to see what the market is doing. So they are there, and the traditional aerospace is there, but perhaps with a wiser head, they're just waiting to see how this market really plays out and what their role is.
Always more to explore. And we tried to cram as much information as we could in this episode. We had to make 2 episodes. The first one was so chock full of information. So for people out there listening and wanting to learn more and maybe have some questions, where can they go? Where can you send them?
So best place is probably our website, te.com. We have a dedicated landing page for eVTOL. I'm on that page. You can contact me through that. And Matt, I think you're on that page as well.
Yeah, and our LinkedIn, if you want to reach out with LinkedIn, we're happy to connect with you.
Martin Cullen, Senior Manager for Business Development in the aerospace market, and Matt McAlonis, Engineering Fellow for Aerospace Technologies, both with TE Connectivity. Thank you both for your time. So exciting to hear what's going on, and even more exciting to think of what may be happening in the future. So appreciate you being with me today, and thank you for your time.
Thanks, Michelle.
Thanks, Michelle.
And I want to thank all of you for tuning in and listening to our Connected World podcast, of course, brought to you by TE Connectivity. And as they both said, I think you can go to te.com to visit the website there. And there's much more about eVTOLs and what we talked about today and much more. And be sure to watch the first episode. This was part 2. So if you missed the first one, you definitely want to go back and check that out. I'm your host, Michelle Dawn Mooney. Thanks again for joining us. We hope to connect with you on another podcast soon.